We have already talked about methods and how to create methods with and without parameters in the last video. Now let's go directly to the RPG analogy so that we can write some methods with multiple parameters in it. Think about a scenario in the game where the player is driving a car. Now, for the player to drive this car, you, as the god of creation, will have to write the movement script for the car, which would be different from the script that the player uses to control the main character. Now, the movement script for the car will take multiple parameters like horizontal movement, vertical movement, current speed, max speed, boost level, use boost, etc. So, let's create this method by typing private void car movement and then inside the parentheses write the parameters like float horizontal movement, float vertical movement, float current speed, float max speed, float boost level, bool use boost, and then debug.log all these values inside the curly braces like this. Okay, so let's stop here for a second and talk about how arguments that you pass inside the method call are evaluated. The evaluation is done based on the position of the argument in the parameter list. That is, in the case for our car movement method, the first argument that you pass will be assigned to horizontal movement, and then the next will be assigned to vertical movement, and so on. Now, some of you might already be thinking that some methods that you will create might have a lot of parameters in them, and remembering the order of these parameters will become impossible if you are not using something like IntelliSense. So to remedy this problem in C#, you can use something called named arguments. Named arguments free you from matching the order of the parameters in the parameter list of the called method. The arguments for each parameter can be specified by the parameter name, and they will be evaluated in the order in which they appear in the argument list and not in the parameter list. So let's go to the start method and first make a call using the position in the parameter list like this, car movement, and then inside pass the arguments like 1f, 1f, 150f, 250f, 0.8f, false. And with that done, let's make a call using the named arguments but in no particular order like this, car movement, current speed, 180f, horizontal movement, 1f, use boost, true, vertical movement, 0f, max speed, 250f, boost level, 0.3f. And this works too, but what you need to make sure is you use named arguments for all the arguments as above, because if you are mixing and matching positional and named arguments, you have to make sure that the position at which you are placing the named arguments is before its position in the parameter list. And to be honest, you'd just be increasing your work by doing this, so just don't do this. Now, if used correctly, it should be easy for you to understand how this can be helpful. The funny thing is that I've never needed to use named arguments, as IntelliSense in VS Code is quite good, and it makes it really simple to pass arguments correctly without this extra step. But I can definitely understand that if I'm using an editor without good IntelliSense, how named arguments will be a lifesaver. Now let's go to Unity and check the logs. As you can see, both the methods are showing the logs correctly, and that means that the named arguments are working as intended. Going back to the code, now let's modify the car movement method and talk about how, when you define a method, you can specify optional parameters. As its name suggests, Any method call must provide arguments for all required parameters, but can omit arguments for optional parameters. Each optional parameter has a default value as part of its definition, and if an argument is not sent for that parameter when the method is called, then the compiler will use the default value in that place. Optional parameters are defined at the end of the parameter list after all the required parameters have been listed. As you can see here, just to show what this all means, we have made max speed, boost level, and use boost parameters optional by setting a default value for them in the method definition. If there are multiple optional parameters like we have here in our method, and the caller provides an argument for any one of these optional parameters, then the caller must also provide arguments for all the preceding optional parameters that are before it in the parameter list. That is, if you pass an argument for boost level, then you also need to pass an argument for max speed, but it will be okay to not pass an argument for use boost. Comma-separated gaps in the argument list, like this, are not supported and will cause compile time error, as you can see by the red underline here. However, if you know the name of the parameter, you can use a named argument to accomplish this task and not give arguments for the preceding parameters, like this. So, to reaffirm again, optional parameters are parameters with default values assigned to them when you define them. And if you pass an argument for these optional parameters when you make a call to the method, then the passed arguments will be used instead of the default values inside the parameters. And if you don't pass an argument for these optional parameters, then the default values will be used when you use these variables inside the method's code block. Another thing is that if you have IntelliSense working in VS Code and you hover over the method call, you will see a dialog box like this appear that shows you the method definition. Here, the parameters that are within the square braces are optional parameters. Now let's modify one of the method calls so that it will only pass required arguments like this. And we already have this other method call which uses named and optional parameters. So let's go to Unity and check the logs. As you can see, in this debug.log, we are using default values for all the optional parameters, while in the other debug.log, we are using both the passed argument and the default values. Back to the code. Now this is a bit important, so pay attention. Let's first copy and paste the car movement method and modify the debug.log inside the method, and also remove the optional parameters from it, like this. So now these two methods have identical required parameters, while only one of them has optional parameters inside it. Some of you might have already realized that this would be a huge problem, as if you make a method call right now with arguments that only fulfill the required parameters, you don't know which of these methods will be called, and that sort of ambiguity is never good. This is where the concept of overload resolution comes into play, and will help you understand how the compiler will decide which of the two methods to use when the method is called. So in a case like this, where the compiler is faced with a choice where one method does not have any optional parameters, while the other contains one or more optional parameters, and both of these methods are otherwise completely identical, the compiler will select the method that does not have any optional parameters. Now let's go to Unity and check the logs. As you can see, we have printed the debug.log inside the method without optional parameters. Back to the code. Now in the method without any optional parameters, let's consider adding one optional parameter. Now some of you might be thinking that the compiler will pick the method with one optional parameter as it has less number of optional parameters than the other method. But if you think so, then you are wrong. In this case, as both the methods contain optional parameters and require default values to be filled in by the compiler, as they are otherwise identical, the compiler will raise an error. The fact that one of the method only requires one optional parameter while the other requires three optional parameters is completely irrelevant here. But here, if you pass an argument for max speed like this, as you can see, the error is gone. If you hover over the method call, you can see that it is calling the second method. The reason I believe this is happening is because all the parameters for the second method have argument passed to them, while in the first method, there are still two optional parameters that need the compiler to fill in the default value. If the second method also had another optional parameter, like this, for which we did not pass any argument in the method call, then we would get an error again, as both the methods need the compiler to fill in default values to at least one optional parameters. Again, the fact that the second method requires a less number of optional parameters is irrelevant here. If you are really interested in this topic, then I would suggest that you read about how overload resolution works in C#, as this topic is quite important. Also, this does not end our journey with methods, as there are still things to cover about methods that are pretty important. But again, just like the previous video, as this video is already more than a bite size, I'll be covering all the remaining things about methods in the next video. Well folks, that does it for today's video. Hit that like button and subscribe to the channel if you like the content. Do comment below if you have any doubts or if you just want to share your thoughts. And as always, if you see someone struggling down in the comment section, do try and help them. Goodbye for now. This is your host VP signing off.